Okay, let's move to the next task team reporting. And I think it's Daniele Chiani, who will report on the task team for climatology and level 4 intercomparison, IC.
Good morning, everybody, and hello, everybody online. So I will report on the activities of the climatology and level 4 intercomparison task team during 2024-2025. So I just would like to stress this is a joint effort from all the task team and Jorge Vasquez Cuervo, who unfortunately couldn't make it for the in-person meeting in Copenhagen. So thanks, everybody. This is the list of current members. It's we have a large number of interested people. In green, highlighted the ones who joined last year. If anybody is interested to join, do not hesitate to contact Jorge or myself. Briefly recalling the main purpose and objective of this task team is to intercompare various SST analysis provided by agencies even through operational services, with the main purpose to guide users to understand key strengths, weaknesses, and advantages for specific applications. We've been thinking about the expected closure of this task team, and at present, the plan is to continue through 2025-2026 to ensure progress in all the ongoing tasks that you will see detailed later on in this presentation. And now we move forward with a summary of activities through 24-25. So firstly, thanks to Erica, we could set up an ICTT SharePoint with the main purpose to facilitate flow of information between task team members, but also the science team community and students, anybody interested with this, with our activities. And this SharePoint includes meeting recordings, presentation, and also meeting minutes with the highlights also of the Q&A session. We also updated the GRIST ICTT website with the same purpose, and we plan to do this regularly every time we have updates on the ongoing tasks. During 24-25, we held 6 meetings, so roughly bi-monthly frequency. A first and a last meeting to have a wrap-up from past activities, and then the last one to agree on the task team report and report presentation. And in the middle, we had a bunch of science talks that were held by the different task team members that we are going to present briefly. So we had a first contribution from Jorge Vasquez Cuervo on marine heat waves. And this is an example of intercomparison of level 4 datasets, namely the Coral Reef Watch and the MUIR level 4 SST for marine heat waves detection around Hawaii on a 20 years time period. So this exercise made by Jorge will also give more detail in a presentation later this week. Is the differences in distribution of marine heat waves due to these two level 4 SSTs currently provided at different spatial resolution. And this triggered some questions, discussion on the role of resolution for the detection of marine heat waves, also in perspective of future missions. Marwan Bouali from ORBTI presented some results on this multidimensional dynamic data fusion system. In the example you see in this slide, this has been applied to sea-surface-side SWOT data. Left and right, respectively, you see the effect of the proposed, let's say, mapping, level 3 mapping algorithm compared to a standard time aggregation with the advantage of gathering of many artifacts in the data aggregation. So as I mentioned, this is applied to sea surface height, which can also be useful for SST mapping, but it has been applied in the past to sea surface temperature, and there is the plan to continue working for sea surface temperature and also ocean color data. And one of the main outcome of the science talk is that a thorough validation plan is scheduled and will give us more details on the results of this algorithm. Prasenjit Das contributed with a very instructive talk on the use of level 4 datasets. Here you see an example from sea surface temperature, and in particular the ESA CCI version 2.1 to estimate trends at global scale. And Prash also contributed to 2 publications that are listed here in this slide. He also provided lots of nice details on technical steps that have to be done to get to maps like this, and it was very much appreciated by the task team. And so for the moment, he presented this work on SST, where you can recognize the high, let's say, hotspots of ocean warming trends, especially located in the northern hemisphere. But he also presented some results on sea level and ocean chlorophyll, and he plans to continue in the future to cross-link all these variables to get more hints on climate variability. Andrea Pisano from CNR presented the main bases and evolutions of the suite of level 3S and level 4 sea surface temperature products currently provided through the European Copernicus Marine Service. And he mainly focused on the scientific evolutions of all the level 3S and level 4 products, also highlighting the effort of the entire consortium in this. And you will see more details in the presentation later this afternoon by Andrea. Quick wrap up on the ongoing activities. We have quite a lot. The first one is related to the validation of SST at different levels using sail drones. We have examples in different areas of the world ocean, as you can see in the publications at the bottom of this presentation, but we also had a collaboration with students from the French Naval Academy to test this validation methodology in the Mediterranean Sea. We have a poster, and you are invited to come and ask questions later today. Another task which is dedicated to the production of visualization tools for level 4 SST, including additional information, as you can see here from France. In particular, here we are looking at the NOAA Ocean View system. Some of the results of the science talk from Prasenjit Das have also been included to facilitate users taking a look of all the applications that can be generated using level 4 sea surface temperature. Another task which is related to the an innovation of including infrared and microwave SST observations in regional basins within products that are routinely produced or planned as evolutions for the Copernicus Marine Service. So this generated already a publication related to a numerical study. We are currently working through a collaboration with DMI on the ingestion of these data sets in the using real data in the Baltic and Mediterranean Sea. And we likely plan to have an update through next year. One task related to the validation of SST gradients and front with other data sets. We didn't really progress for this talk. We are still looking for ways to go for the next year. Some preliminary discussions with Jorge evidenced the issues in relying on in situ benchmark to validate SST gradients, but it will be a matter of discussion certainly in our next meetings. Another task which is related to the intercomparison of level 4 SSTs currently available through operational services in terms of feature resolution and also distribution of SST gradient values. So during the last year, it was done as a support for the Copernicus C3S climate change service and also the Copernicus Marine Service as intercomparison exercises. There are no public results yet. Some of them will be soon released through the Copernicus Climate Data Store under the shape of Jupyter notebooks, and quick wrap-up summary of the main results of the scientific activities, and likely a paper is expected also during the next year. A last task, which is focused on the study of SST fronts, but also ocean color fronts, which is based on the work presented by Marwan Bouali from ORPTI, that also we plan to continue through 2026, and it's related to the adaptation and evolution of the M3DFS algorithm to generate new SST and ocean color products that are aware of the realistic oceanographic fronts. So with the aim of getting rid of any level 3 interpolation artifacts, generation artifacts. We had a series of discussions to highlight some challenges and needs for the next year. So with Jorge, we identified potential interactions with 2 task teams. Certainly a meaningful one would be interaction with a high latitude task team, where intercomparison can also be useful to understand strengths and weaknesses of the level 4 SST that can be produced, and even the high resolution task team in perspective of future missions, even for the definition of coastal masks for the observations of coastal processes at very high resolution. And a major challenge that also came out as an outcome of the discussions we had late in one of the last meetings. We have several ongoing tasks, and we need to converge, trying to maximize from considering the outputs of many of them, and converge, involving a number of task team members to a common study that potentially could generate also publication as a guidance for users interested in the level 4 sea surface temperature. This was my last slide.